can tell what feeds on it, like maybe a colugo or the flying squirrels come for it. Just mention that animal. You may not see the animal, but you know what feeds on it. In the daytime, if a giant squirrel comes, even better. But I think they're a bit afraid now because of this construction. But once they settle down and there's no more banging sounds, it's going to be really good. Yeah. Then I like to, in a way, I like biomimicry.
Yeah, that's a nice word. Biomimicry. Do you guys have that? Okay.
Bio is life. Mimicry is imitate life.
Okay.
Now, if you look at the leaf, what was it called here?
Campnospermum.
Yeah. See.
It's big. It's one of the.
Yeah. Sunlight is the most important commodity in the rainforest. And you see how clever this tree designs its leaves to capture maximum light. They have their leaves in a rose petal fashion. So, and they have it at the end of their branch rather than along. And every leaf has a look at the sun. Yeah, so it's like a dish collecting as much light as possible. But in the tropics, you have to deal with heat as well. So you can see the leaves that are higher up are angled much higher. So they get just, if the best to get sunlight is to present your leaves 90 degrees to the sun, right? But then you have a problem of heat. And with heat trees control heat by transpiration, manage heat by transpiration. So you can see that the first leaves, the early younger ones are slightly angled. So this way they can take enough light but don't build that much heat. The leaf that is behind it has partial shade, so they can be open more and more and more. So, and this is what architects are trying to design buildings in the tropics that allow enough light in, but at the same time manages heat. So you don't have to spend energy. So that's one biomimicry thing you can tell. And I'm sure you can find new topics from some of the other trees, how they manage heat.
Right.
And
Another
so forth.
biomimicry is Velcro. Do you know this word, Velcro, which two things stick together? They actually imitated seeds that have hooks. You know how seeds stick to your socks sometimes? So that's how they invented Velcro, because they looked at seeds sticking and said we could make something with lots of little hooks that sticks, and then you have to pull it off. So biomimicry is a fun thing to look for.
To show, and how that's relevant to design architects today and so forth.
Right.
Yeah, that's a nice way of looking at it. And there's a beautiful website by Janine Benyos.
Yeah.
She's the lady who came up with
she's a good
it.
friend of mine, actually. She's
Is
lovely.
she? Oh,
yeah,
I'd love
I've
to
worked
meet
with her a lot. I would love you to come over and meet her.
She's
and,
one of my heroes.
Dana Bauermeister was a student of mine. Is her like VP, vice president. So that's why I got lucky to get an in.
Right. Well, I think those who got great potential here should do there are some courses in Biomimicry Institute. You can do some foundation things. You can do online certification. If you really want to go all the way, then
they're taking shark skin, for example, because no barnacles grow on shark skin, and they're trying to imitate for paint for boats. You know, so those are the kind of things she thinks about, which is really creative.
The Japanese came up with this long time ago. You know the bullet trains? The Kingfisher. You know this story, right? So when you just shift, you can do a little part on biomimicry, talking about that and relating to some products your guest has seen and experienced.
Right.
You know, have you heard of the bullet trains? They were called bullet trains because in the initially designed, they were shaped like a bullet. And every time it entered a tunnel, the density of air was greater inside than outside. And as the train pushed through the tunnel, they built up so much at the exit point of the tunnel, there's always a boom sound. And this is not one or two trains a day. It's in Japan, in Tokyo, it's many services. And they could hear the sound 800 meters from the exit. And the Japanese complained. It so happened that the chief engineer of Japan Railways was a bird watcher. And he wanted to go in nature. First he wanted to go in nature to see what in nature traveled from one lighter medium into a denser medium, and it's the kingfisher and how it enters the water. So just one or two stories like this. Don't go into, I mean, if they ask, that's great, follow up. And then of course all that you said just now, just wonderful.
Stories, always stories in between everything. And just a few facts. Like I think 100% light up top, 1% on the forest floor is really shocking. That people think, wow, it's pretty dark down there, and how does the leaf survive? And what we just talked about. And I think you need to always stop too. I think one thing people do on a walkway is they keep walking. So your guides will have some nice stopping places, and then you could pick out two things. One is always birds, always mammals, but if they are not around, then you're stuck with plants. But you can see the tree ferns, which is a nice shape, and you can see palms, which is another nice shape. You can see new leaves are reddish in the rainforest. That's amazing because that's a pigment. In the temperate forest, they're red at the end of their life. In the tropical forest, they're usually reddish at the beginning. That's kind of a mystery still to scientists. Is it deterring insects? Is it protecting from sunburn? There's a lot of reasons why people are not positive, but they're making what we call a hypothesis. But you can pick these things out, and then you can pick out the layers of the canopy: forest floor, understory, mid canopy, upper canopy where we are, but then emergence are the ones that stick out over, and they tend to have a lot of that architecture that you could mention about the leaves and how everything is, and that's where you get a lot of orchids and vines and bromeliads because they love to be in a little bit of light. They need those taller trees. Like there's a great example behind us right now. See all the epiphytes in that tree because they really get their share of light. And they probably won't be growing down at the bottom so much, and they love being in a big old tree like that where the sun is hitting them. I study leaves. That's pretty boring, but I try to have to make it fun. So, you can pick up a few leaves before you start out. Like I picked this one up over there, but mind you, I didn't have to bother because there's so many. But look, this one is dying. It's turned yellow, so there's another color in the forest. But also, I love to look at what's eating it, because one thing about trees is they can't run away from their enemies like a bird can. A bird can fly away, a monkey can run away, but a tree is stuck, always in the same place. So that's a pretty challenging life, If you couldn't ever move, it means you have to attract your your pollinators. You have to keep from getting eaten 100%. And so a lot of things are eating these leaves, obviously, and probably there's chemical in this leaf. Some leaves have thorns, some leaves have hairs, some leaves have some kind of toxin that keeps the insects from eating them, but some insects are adapted to eat the poison. The same way that you guys might eat hot chilies, and I sure don't. I don't know, do you eat hot chilies?
Not that hot. Not the one, the jalapenos or whatever they
different
call them.
kind of people.
The ones from Mexico.
Different diets, but you can pick up a few leaves, and you can also feel how waxy it is.
And some leaf miners.
Yeah, leaf miners that put little tunnels around the leaf and suck part of the leaf, but don't chew it all the way through. And sometimes you can find little galls on the back, little bumps, and I call it leaf detective work. That's what the students were doing for me this week, is becoming leaf detectives, because we were measuring the amount of damage. And the one thing another number, you don't have to remember all the numbers, but by sampling a whole tree, one of the things I found is the first person to do that was there's 4 times more insect damage than what scientists thought when they were only sampling on the forest floor. So they were doing that, remember, up till 1980 when I told you that I started the rope thing. And then when I studied the whole tree, wow, there's a lot more insect damage, because obviously there's more foliage at the top, there's more beetles at the top, and more turnover of the leaves at the top. And also shade leaves, they're called. See how down at the bottom they're darker colored, and up high they're lighter, because the leaves in the canopy have to be really good to resist wind and dryness, because it's really like a desert at the top of the tree. And Down there it's shaded. They're going to get covered with moss and lichen, and the leaves can be bigger because they're not in a big monsoon wind at the bottom. So, and they live longer actually down there. It's a little quieter and easy to deal with. And probably from the tree's point of view, you wouldn't want to put a whole lot of leaves out every year down in that 1% shade anyway. So there's a lot of what I call the energy budget of a tree is very complex. You know, who's photosynthesizing and how long do you keep your little factories? These are factories for manufacturing energy, and when do you turn them over, and how do you avoid being eaten, because these are your lifeblood, your factories. And so it's kind of very complicated without too much effort. All of a sudden you're like, how many leaves are on a tree anyway? And I hope one of you will answer that question, because I don't know.
There's also the drip tip you find on the leaves, but this is none.
This is
But
not.
it's shaped this way, so anyway the water is captured and sent towards the
Right.
center.